Good morning, students. Welcome back to science class in the chapter work and energy. Okay. Yes. In the previous class, we had studied about mm, kinetic energy and potential energy. Okay. So in this session, we will derive expression for kinetic energy and expression for potential energy. Okay. First, we will derive expression for uh, kinetic energy. That is, kinetic energy is equal to half mv square. Okay. Yes, how to start. Here we need half and so m and v square. Okay, the kinetic energy of an object, it depends on velocity of an object and mass of that object. Okay. Yes, how to start the derivation. Yes, if you know the answer, please put it in your comment box quick. Okay. Yes, sir. See here. Here we need mass and velocity, right? So consider one object. Its mass as m. Okay. Consider an object. Its mass as m. And see here we need velocity. When velocity, because when the object is motion, then only we can calculate the velocity, right? So consider an object. Its mass as m, and it is moving with velocity v. Okay, and it is moving with velocity v. Okay. See, sorry, it is moving with initial velocity u, and due to the application of force, okay, its velocity changes from v to u. Sorry, u to v. Okay, let force F act on a body. Okay, and it produces acceleration a. Okay, so consider a body, its mass as m, and let the force acts on it. Okay, and it is moving. That object, it is moving. Its velocity changed from u to v. Clear? So now, how here we need kinetic energy is equals to half mv square. Okay, kinetic energy is equals to half mv square. But how to start? How to bring half mv square? Okay, so for that, see here. Here we have to consider equation of motions. Here we have to use equations of motion. That is third equation of motion. Okay, and see here. First here we have to consider an object. Okay, first here you have to consider an object at rest. Okay, and its mass as m. At rest, its initial velocity is equal to 0, right? At rest, its initial velocity equal to rest. So later, so just imagine, let the force F acts on this body, then its velocity changed from u to v. Okay, so first consider body. Initially it is at rest and its mass as m. Okay, let the force F act on it. Let the force F act on it, and its velocity changed from say u to v. Okay, yes. So now using third equation of motion, what is the third equation of motion? That is v square is equals to u square plus 2as. V square is equals to u square plus 2as. Okay, yes, its initial velocity equal to 0, right? Because initially that object is at rest. Okay, so v square is equals to initial is 0, that is 0 square plus 2as. Okay, s means what? That is distance covered by an object, right? So that object is at rest. Okay, its mass as m, its initial velocity equal to 0. So you will apply a force. You will apply force on it. Then its velocity changes from u to v. Okay, and it will cover some distance, right? So I'll take that distance as x. I'll take that distance as x. So v square equal to u square plus 2as. Okay, so then we can write, so v square is equals to 2as. V square is equals to 2as. Okay, now arrange the equation for s. Bring to a this side, that is v square divided by 2a equal to s, or we can write s is equals to v square divided by 2a. Correct? So s is equals to v square divided by 2a. Okay, now see here we have applied a force on that object, so we can calculate work done, right? Because see, when you apply a force, if you want to say work is done, there are two conditions are necessary. One, applied force; another one, that object should cover some distance. Here we have applied a force, then it covered some distance or displacement, so we can calculate work done, right? So now work done on that object, that is W is equals to force into displacement. Force into displacement. Okay. Now see here, force means what? We can write force is equals to m into a, right? Force is equals to m into a. So W is equals to m into a into s. Here we got s equal to v squared over 2a, right? So now substitute here. That is v square divided by 2a. Okay, so a get cancelled, right? So that is W is equals to mv square divided by 2. Okay, now so we can write half mv square. Okay, so we got square. Okay, so now, so here we got work done is equals to what? mv square. But we need kinetic energy equal to, okay, so work done is equals to half mv square. But see, actually we need kinetic energy is equals to half mv square. Here we got work done equal to half mv square. Okay. Yes. Now tell me what is the correct answer. Sorry. Next, how to bring that work done equal to kinetic energy? In the previous class we had studied, right? We will express energy in terms of work done. So that's why kinetic energy is equal to work done. Okay. So that's why here work done is equal to kinetic energy. Means here, here we express that energy in the form of work done, right? So that's why work done is equals to kinetic energy. So finally we can write kinetic energy is equal to half mv square. Okay, see, very simple one. See here, first to derive this one. So first we should consider one object. Its mass as m, and initially that object is at rest. At rest, its initial velocity is equal to 0. Correct? So let the force F acts on it. What will happen? Its velocity changed from u to v, and it has acceleration a, and it will cover some distance s. Okay. Now using third equation of motion, v square equal to u square plus 2as. Here that object is initially at rest, so that's why its initial velocity is equal to 0. So v square equal to 0 square plus 2as. So v square is equals to 2as. V square divided by 2a equal to s. Okay. Next, s equal to v square divided by 2a. Here work done equal to force into displacement. Clear? So and here work done is equals to F means ma into s equal to v square divided by 2a. So a get cancelled. So work done is equals to m v square divided by 2. So take half outside. So that is half mv square. In the previous class we had studied energy is nothing but it's a work done, right? Okay, that energy is converted to work done. So that's why energy equal to work done. Here kinetic energy is equal to work done. So that's why kinetic energy is equal to half into mv square. Okay. So simple one. If you have any doubts here, please ask. Quick. So next we will derive potential energy. Derive potential energy. Here, Channu Patil answer my question. Excuse me, sir. There is a doubt for me. Increase in energy against gravity is called a gravitational potential energy. In the same way, is there any other forms? See, here, listen here. When you raise an object, it will fall down. When you drop that, it will fall down. Why? That is due to the gravitational. So that's why here we are using gravitational potential energy. Okay. Compressed spring. Okay. Or compressed spring, there we can't use this for potential energy equal to m into g into h. Okay, there we use half kx square formula to calculate potential energy. Okay, see, that is different. That compressed spring, it releases, right? So that is different, but here we are lifting that object against the gravity, so that's why we call gravitational potential energy. Okay, so we can't use that potential energy, that m into g into h formula in a compressed spring. There we can using that formula, we can't calculate potential energy. Okay, there we use half kx square in studying your higher classes. Yes, next move to potential energy. Okay. Yes, sir. You know the formula. Potential energy is equals to m into g into h. Okay. So here our work is to prove that potential energy is equal to m into g into h. Okay. Yes, sir. How to start here? Yes, sir. Very simple one. Okay. If you know the answer, please put it in your comment box. Quick. Yes, work done equal to force into displacement. But no, how to start? First in the first example we have started, right? We have considered one body and its mass as m and its initial velocity was equal to 0. So like that. Okay, see here. Here also consider one object. Okay, so this is not, here also consider one object. Its mass as m. Okay, so now just imagine this object is raised to a certain height. This object is raised to a certain height. If you want to raise the object, here you have to apply a force, right? So without force, you can't raise that object to a certain height. Okay. So here, if you want to raise to a certain height, then you have to apply a force. That force has F. So here you have applied a force, and that object is raised to a certain height. That is, I will take it as h. I take that as h. Okay. So now here we can calculate what work done. Okay. So we can calculate work done. That is, W is equals to force into height. Height means what? Displacement. Displacement equal to height, right? Yes, sir. What is the force formula? See, actually force is equals to m into a. Okay, m into a. But here you are lifting that object against gravity, right? While falling downwards and while when you throw the object against gravity, at that time we use this formula to calculate force. We use this formula, that is m into g. Okay, here g is also acceleration. Here g is also acceleration, but this is acceleration due to gravity. Okay, so here g means what? Here g is also acceleration, but due to gravity. If you want to calculate force, see, you have to multiply mass of the object and its acceleration. Correct? Here g is also acceleration, but this is due to gravity. So that's why here force is equals to m into g, and height is, that is h. So we got work done is equal to m into g into h. Work done is equals to m into g into h. See here. Now this energy is converted into potential energy, right? So that's why work done is equal to potential energy. Okay. So finally we can write potential energy is equal to m into g into h. See, very simple one. Okay, it's very simple. Yes. So now I will give you notes. Okay. First, expression for kinetic energy. Expression for kinetic energy. Okay. Yes. First, consider a body. Consider a body. Body of. Consider a body of mass m at rest. At rest. Let a constant force let a constant force F act on the body, producing an acceleration a for a distance s. For a distance s. Okay. Let the velocity of the body be. Let the velocity. Let the velocity of the. Let the velocity of the body be changed to v. Okay. So here consider a body of mass m at rest. Let a constant force F. Okay. Sorry, capital F. Let a constant force F act on the body, producing an acceleration a for a distance s. Let the velocity of the body be changed to v. Okay. Yes, sir. Next, here the initial, see, actually initially that object is at rest, right? So that's why its initial velocity is equal to 0. Since initial velocity is equal to 0. Okay. and its final velocity is equal to v. Okay, and final velocity is equal to v. From the equation, we know that, right? That is the third equation of motion. V square equal to u square plus 2as. Okay, v square equal to u square plus 2as. Next, v square equal to 0 plus 2as. So we can write v square equal to 2as. Okay. Next, arrange equation for s, that is v square divided by 2a equal to s. So finally s is equals to v square divided by 2a. Call this equation as 1. Okay. So here no need to write this one. You can write directly this one. Next, the work done on the body during displacement, yes, during the work done on the body during displacement yes, during displacement, yes, during displacement, yes, is during displacement, yes, is, that is W is equals to force into S. Okay, work done equal to force into X. Then force is M into A. Then S equal to V square divided by 2A. Okay. And so A get cancelled. So finally we got W equal to MV square divided by 2. Then so W is equals to MV square divided by 2. Right, I will write here. Right. W is equals to half mv square. W is equals to half mv square. This work done is equal to the this work done is this work done is equal to the kinetic energy of the body. This work done is equal to the kinetic equal to the kinetic energy of the body. Body. Kinetic energy of the body, that is Ke equal to half v square. Okay, so this is an expression for kinetic energy. Yes, next expression for potential energy. Next expression for potential energy. Okay, sorry, expression for potential energy. Consider a body. Consider a body. Consider a body of mass m. Of mass m. Mass m is raised from the ground level, from the ground level to a height h. Okay, to a height h. A force F is required. A force is a force F. F is a force F is required to do this. Okay. Next, the work done is see, don't write this one. Can relate to a height. The work done is work done, the work done is F into H. Okay. Work done is F into H, where F is the force applied. F is the force applied. F is the force applied. Okay. Next. Yes, next we know this one. So work done is equals to F into H. F means what? Here that is M into G. M into G. And here add one more sentence. Add one more sentence. The force F, the the force F, the force F, the force F on the body against which which the work is against which which the work is done. The work is done is equal to the weight is equal to the weight mg is equal to the weight mg of the body. Okay, here no need to write these sentences, just you can write in your own words. Okay. See, consider a body of mass m is raised from the ground level to a height h. So the work done is F into applied. The force F on the body against which the work is done is equal to the weight mg of the body. You know, right? Here that work is done against gravity. So that's why force equal to, we should take force equal to m into g instead of taking m into a. Okay. Yes, then work done W is equals to force into displacement. Here displacement is H, okay, that is M into height. So sorry, take S here. Okay, so S is equals to H, right? So work done is equal to M into G into H. You know, right? This work done is equal to what? This work done is equal to kinetic energy of the body. Okay, this work done this work done is this work done is this work done is equal to the this work done is equal to the potential energy of the body. Okay, equal to the potential energy of the body. Okay, this work done is equal to the potential energy of the body. Yes, work done equal to potential energy. So then we can write potential energy is equal to M into G into H. Okay. See, both are very simple. Okay. These two are explained important for 4 marks. The expression for kinetic energy and expression for kinetic energy and expression for potential energy. Okay. I will stop here. In tomorrow class, we will discuss some problems using kinetic energy and potential energy formula. Thank you.